So I got these new speakers and they're really good. I really like the audio on them. I can't really fault them for that, but there is one little thing I would nitpick on, and that is the control. They come with this little puck remote control which allows you to turn them on and off, do volume up and down, and you can change between 4 different EQ presets, or processing modes, I guess they're probably more accurately. The leftover slightly odd button at the bottom of the puck is input source, that allows you to cycle through the different inputs that the speakers accept. And there's quite a few of them. I think there's 5 or 6 different inputs, but you can only step through them one at a time. And as you enter a new input mode, it seems to boot or run some initialization script, and that locks it in for just, I don't know, half a second before you can think about moving to the next mode. So it's very much a click and wait, click and wait, click and wait, click and wait to get round to where I want. What I'd like is the ability to be able to jump directly between the 2 modes that I'm using commonly, the optical input and the Bluetooth mode. Now, to cycle between them is a number of steps, so it would be great if the remote control had a button that would let you just go straight to the mode you wanted. There isn't a button like that on my remote control, but I suspect it might be possible because other similar speakers in the range have similar remote controls that do have the ability to directly select the input you want from a button on the controller. What we'll try is we'll look at the codes that the remote can send and see if we can figure out any codes that are available but not on this remote that might allow us to jump directly to a particular input. I had a bit of a false start trying to use a Pi Pico for this. I ended up going back to a trusty old teensy 3.2 microcontroller. With the IR remote library and compiled through Arduino, I managed to record the outputs from my remote control. We've got a dump here of the captured code. It's an NEC code. The library handily decodes this all for us and tells us that it is indeed NEC format. It has a 2-byte address, E78, and for volume down it has 1-byte command, OF. Here in the raw data you get the complement of the command followed by the command itself, and then followed by the 2 bytes that make up the NEC address for the speakers. The address is the same for each function on the remote, so it's only this one command byte that we've got to play with. For all of the buttons on the remote, we've pulled out the command. To change to classic, byte 0, vocal 1, play pause is 2, next is 3. The vital one here is source. Source is 0D in the command byte to change to the next source. So if we look at these codes across all the possible values, first 4 slots are used, and then there's this likely looking gap here before 4 more slots are used, followed by another likely looking gap, and then the on-off code is down here. The only 2 unusual ones is that previous is way down here at 64 and monitor is way down here at 76. I can't really see any logic behind this grouping, but it is all in this lower portion of this address space. So if I'm going to try and find other codes that might be hidden there, the most likely portion is going to be this gap here, probably followed by this gap, and then as we go down into this other space, I think it probably gets less and less likely that the engineer has put a code in there. My hope is that one of these codes here will jump to a particular input mode. I mean, it would be cool if, say, 4 was Bluetooth and 5 was optical and 6 was coax. But we shall find out. The first step in this process is going to be to replay these codes from the teensy to the speaker to make sure it'll recognise known codes before I go about trying to work out if these are valid codes or not. What you can see here is an OLED screen that says Start, and next to it is an infrared LED which will transmit the codes shown on the screen to the speaker behind. The speaker has a little black bar with these indicator lights on that flash when a valid code is received. We're going to cycle through the 9 known valid codes, checking that each one is recognised by the speaker. Each time the number on the screen changes, a new byte has been sent from the LED, and you should see a flicker, which we do on the speaker display. So the speaker is recognising all of these commands as if they were coming from its own remote control. So now I'm sending the codes that are not on the remote control, starting with the most likely lower range, just looking to see if there's a flicker of recognition from that speaker that a valid code has been received. We're getting through that range of numbers now. I'm playing this back at double speed for you. In real time, I put a 4-second delay between each code to give the speaker a chance to respond. And we're finishing up here on 4B. The highest code on the remote control was 4C. So we've just tested all of those slots up to here, decimal 76, and none of the ones other than the ones in green here have proven to be valid control codes for the speakers. We'll try everything above that now. We finished up there on FE, so we've now tried every possible other byte that could cause the speakers to jump directly to one of the input modes, and sadly there just doesn't seem to be one. So I guess at least for now I am stuck cycling through these modes just using the source key. Well, thank you for watching, stay safe.